class, but I'm going to go through them again. Try to give you some strategies on how to do this. So if you have a matching like this for problems 1 through 10, you're going to match the standard form, that's the numbers on the left, with the correct picture, the correct words, or the correct expanded form. So when you approach a problem like that, one idea is just to look at what you have on the first one and say it out with your words. So this is 300, and the decimal is the word and. 300 and, you have 2 decimal places, tenths, hundredths, so it's 327 hundredths. So it can't be 327. So you just go through all of these. Look at D, 300 and, so that's 327 thousandths, tenths, hundredths, thousandths, so the 27 would have to go here. And that doesn't match. So look down here, and you have 300, and if you think about lining up decimals, you add the other 2 pieces of that problem, and you get the 300 and 27 tenths hundredths. So G is the correct answer. Cross out G because you can't use it twice. For the second one, with words, that's 5 tenths. So 5 tenths can also be written as 5 out of 10. It could be written as, if you divide it down by 2, divide down by 5, you get 1/2. So it can't be A or B or C. None of those are 1/2. Neither is D, E, or F. So we're down to 5 pictures because it also can't be 3/4. So this right here, H is 3 squares out of 10. That's not 1/2. J is 10, this is a hundredths plate, squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 100. That's not 1/2. These are not 1/2, so it must be K. If you look at K and divide it up a little bit, you can see that exactly half of the triangles are purple and half of the triangles are white, so half of the hundredths plate is shaded. So that's kind of a tricky one. But the correct answer is K.
Do you need Gola to the main office?
Okay, so number 3. So one strategy I was doing was going step by step. But you could also just look at the grids, because most people are comfortable with the grids, and figure out what they are. Like this is 24 out of 100. So standard form is 0.24 because it's 24 hundredths. And remember, all of the problems are in standard form. So if you can find the standard form for each grid, that might be a good strategy too. So that matches with L. Number 3 does. So now we're done with L. This is 3 out of 100. So 3 100ths, tenths, hundredths place. You have to put the 3 in the hundredths place, which means we fill that in with the 0. So that's the other strategy. Just try to find which pictures you know the answer to, and go out of order over here. So number 5 is M. So we've used M. And then this 10 out of 100, that's the same as 1 out of 10, which is also 1/10. So I don't know if you can see that on the video, 1/10. In other words, 10 out of 100 reduces down to 1 out of 10, and that decimal is just 0.1. So that's number 7. That's J. And then H, we already said was 3/10. That's 3/10. That's how you write it in standard form. So scan through, and there is no 3/10. So we don't use H. There's more choices than there are problems, so we're not going to use H. That helped us with a lot of problems just using the pictures up. Go back to number 4. That's just 327. I know you guys think that one's easy. Cross out A. So we're left with B, C, D, E, F, and I. Sometimes just looking at each one and seeing if you could write it in fraction form. So 2.5, another way to say that is 2 5/10. There's only one number that looks close to that. If I divide by 5, get the half, so C is 2.5. 75 hundredths as a decimal can be written as 75 over 100. 25 goes into both of those like quarters. There's 4 quarters in $1 and 3 quarters and 75 cents. So 75 hundredths is the same as 3 out of 4, or the fraction 3/4. So this is I. Now we're just down to number 6 and number 10. So number 6 has another decimal with the word and in it. 236 and 14/10 hundredths thousandths. So 236 and 14 thousandths. That one matches up. E. So we know that 10 is not 300, so we can cross that out. And we know that 10 is not 200 plus something. So this last one, 2/10, and we already used this. So it should be 1/5, but let's check. 2/10 can be written as a fraction. And when you reduce by 2's, the numerator and the denominator, you get 1/5. So B. So that's the matching. There will be a matching section tomorrow. Now we've been practicing these missing numbers in class, and the strategy that I'm hoping some of you are using is first just count the jumps. So 1, 2, 3, 4, 5, 6, 7, 8 jumps. So our step size is an 8. So this is 2/8, which is the same as a 1/4. This is 3/8. This is 4/8, which is the same as a 1/2. This is 5/8. This is 6/8, which reduces to 3/4. 7/8. So my strategy is to fill everything in, even if there's only a few boxes, because it might be easier. So if this is $1, halfway, think of this as $1 instead of just 1, is 50 cents. We've been practicing that in class. And half of 50 cents would be a quarter, which is 0.25 or 25 cents. So then from the problem above, up here, we already learned that 3/4 is 75 hundredths, which is like 75 cents. So if you look at this picture, every 2 jumps, 25, 50, 75, 100. Every 2 jumps is a size of 25 hundredths or 25 cents. Now the tricky part, to get this box, you have to take 25 hundredths and cut it in half. So one way to do that is make it 250 thousandths, because half of 250 is 125. So every little jump is 125 thousandths. If you had to figure out, say, one more box, just for practice, you would just take your 250 thousandths, and since you have one more jump to add, you add 125 thousandths to that. 0.375, 375 thousandths. Okay, number 12. This is one of the ones you're supposed to have memorized. 1/3, 2/3. We've done the decimal division in class, and we get repeating decimals. If you practice the decimal, you'll see that repeating pattern pretty quickly. 3 doesn't go into 1, so we put a 0. 3 does go into 10 3 times. 3 times 3 is 9. When you subtract, you get a 1 and bring down the 0. And then you have the same number again. 3 goes into 10 3 times. Once you see that repeating pattern, you know you're going to have a repeating decimal. And the last one on this page, this is the easier of them. If this was $1, well, first let's see our jump sizes. 1, 2, 3, 4, 5. So this would be 1/5, 2/5, 3/5, 4/5. So we need to figure out what 1/5 is. So if you take $1 or 100 pennies and divide by 5, hopefully you know that's 20 cents. If you're not sure, you're stuck with some long division. Five does not go into 1, but it does go into 10 twice. Then you subtract and get 0, bring down the 0. So 5 goes into $1, and 5 goes into 100 20 times. So $1 divided by 5 is 20 cents. 20, 40 cents. Now we're just counting by 20s. 60 cents. So this is 80 cents. The other way is to use your ratio tables. 4/5, you just multiply by 2, and you get 8/10, which is 0.8. Both are correct. Same with 1/5. Multiply by 2, and you get 2/10. I guess I should explain. Remember, to get to $1, you would go to 100, which would give us 20 out of 100, which is 0.20. Over here, times by 10, you would get 80 out of 100, which is 80 cents. So you don't have to do it more than one way. You just have to have a system to get those missing numbers. All right. So on this next one, compare the following pairs of fractions, then fill in the box with the correct symbol. Show or explain how you did each. Probably the easiest way for most of you is just to get a common denominator. So I could get the denominator of 24 here. 3 times 8 is 24. 1 times 8 is 8. And here we're going to change 5/8 times 3. And you get 15/24. So 15 is bigger than 8. The other way is to explain that 5 is more than half of 8 and 1 is less than half of 3. You could write a sentence. But I think on a testing situation, common denominators are quicker. So here, multiply the common denominator for 5 and 7 is 35. So multiply the numerator and denominator by 7, you get 35 and 21. And over here, you multiply by 5, you get 35 and 20. 20 is less than 21. Here, a picture's nice. It's quicker. This is 0. This is -1. That's -1/3. That's -2/3. Since -1/3 is farther to the right, the bigger numbers are to the right. This one, common denominator would work nice. Just multiply by 2 in the numerator and the denominator. And you get 6/10, so they're both 1 and 6/10, so they're equal. Here, using the memorized fraction from the previous page, that's 3.6 repeating. So that is right here, 2/3. So that's like 66, and 66 is smaller than 75. Since they both have the same whole part, you just need to compare the decimal part. Absolute value of 3 is how you read that. Absolute value. Absolute value means how far from 0 is the number. So -3 is just 3 units from 0. So the absolute value of -3 is just 3. All right. So there's some directions here. Place each fraction between the correct benchmarks. So decide where each one of these go. Then determine where it's closer, which is the nearer benchmark. So is, for example, 2/5. 2/5 on this number line. You could also think of 2/5 in decimals because you see there's decimals here, or that it's less than a half, but it's 4/10, and a half is 5/10. So you're supposed to decide where it belongs. So we know the point that we're going to place is between 0 and a half. But since it's 4/10 and this is 5/10, a half is 5/10. 4/10 is going to be closer to a half than it is to 0. So then you just put label A there and a point. So for point B, we know it's 1 3/8. So since 3/8 is the next one I'm going to compare, I'm going to write 1 1/2 as 1 4/8. These are the same, which helps me place 1 3/8 closer to 1 1/2 than it is to 1. So you don't have to be super accurate, but you want to be closer to the correct benchmark. For point C, 3/4, that's halfway between, because if I take my whole and divide it into 4 equal parts, halfway is point C. So it's exactly in the middle. And point D, that's the same as 1/10. So that brings us back to the tenths. If 1/2 is 5/10, 1/10 would be about here. D. So you just place your point and give it the label. This was like a homework problem, number 16. On your test, I changed the numbering. Maybe not on this page. So 4/5 and 5/5 seem like they're right next to each other, but there's lots of numbers in between, which is a little tricky. But since we can't say 3 1/2 we have to change the denominator. So try doubling. Times by 2, and you get 8/10. And if you multiply both of these by 2, you get 6/10. So 6 something 8, this has to be 7/10. The other way is to think of it as 3.5 over 5, and you could just double this way. 3.5 times 2 is 7, 5 times 2 is 10, so the missing number is 7/10. Okay, remember, I'm working through this fast, but you can always press the pause button. So the ratio, so probably thinking ratio table, of boys to all of the students in Mr. Chu's class is 12 to 30. So we know we have boys, and we have a total. But the first question says, what fraction of the class is girls? So we really want to make a table with boys, girls, and total. So the ratio of the boys, again, to all of the students is boys to total is 12 to 30. That must mean when you subtract 12 from 30, you get the girls. There's 18 girls. Because 18 plus 12 makes 30. Now we have to find a fraction of the class that's girls, and we have to find the percent of girls and the percent of boys. Always look at your numbers and see if there's a common factor so you can reduce down. All three of these numbers have 6 in common. So 12 divided by 6 is 2. 18 divided by 6 is 3. 30 divided by 6 is 5. That allows me to get the most reduced fraction. So the fraction of the class that's girls would be 3/5. And then the percent, we have to build that number up to 100. So multiply by 20, and you get 100, 60, and 40. So 40% of the girls, 40% are boys, and 60% of the class is girls. So 40% of the class is boys, and 60% of the class is girls. And these are our percents because it's per 100, and we have 100 in our total column. I'm going to stop here and then make another recording of the next page.